We're going to talk about absolute value inequalities. Remember the meaning of absolute value. Absolute value is the distance away from zero. So if you're asked, what is the absolute value of 7? What you're really being asked is, how far is 7 away from 0? It's 7. Or if you're asked, what is the absolute value of negative 3? What you're really being asked is, how far is negative 3 away from 0? It's 3. So for absolute value inequalities, you want to think of them in terms of distance away from 0. If you have the absolute value of x is less than 5, think about what that means. That's saying that the distance that x is away from 0 is less than 5. Well, there are two numbers that are 5 away from 0. You have negative 5 on the left and 5 on the right. So if the distance that x is away from 0 is less than 5, then x lies in between that negative 5 and 5. Or you could say that the value of x is greater than negative 5, it's to the right of negative 5, and the value of x is less than 5, it's to the left of positive 5. So saying that x is greater than negative 5 and x is less than 5, that's an and inequality. Remember, you can write an and inequality as one string. You could say that negative 5 is less than x, which is less than 5. It helps to see these graphically. If you draw these out on a number line, with the distance of x being less than 5, if you draw that out on a number line, that means x lies in between negative 5 and 5. So the value of x is in between negative 5 and 5, or negative 5 is less than x, which is less than 5. Now if we're going to solve this inequality, it says the absolute value of 2x minus 1 is less than 7. What that means is the distance that 2x minus 1 is away from 0 is less than 7. So if the distance 2x minus 1 is away from 0 is less than 7, it helps to draw these out on a number line. So if you draw a number line, 0 in the middle, you have negative 7 on the left, positive 7 on the right. The distance that 2x minus 1 is away from 0 is less than 7. That means 2x minus 1 lies in between negative 7 and 7. Or you could write that as negative 7 is less than 2x minus 1, which is less than 7. So to solve this for x, that's the inequality that you're going to start with. I'm going to say that negative 7 is less than 2x minus 1, which is less than 7. And then all you have left to do is to solve that inequality for x. To get the x by itself, you remember you have three areas. You have a left, a middle, and a right. So add 1 to those three areas. Add 1 to the left, the middle, and the right. And if you do that, you end up with negative 6 is less than 2x, which is less than 8. Still have to get that 2 away from the x. So divide each of those three areas by 2. Divide the left, the middle, and the right all by 2. You end up with negative 3 is less than x, which is less than 4. So the value of x in this absolute value inequality, the value of x lies in between negative 3 and 4. Now when we started this, the value of 2x minus 1 was in between negative 7 and 7, but we're looking for the solution to this inequality, which would be the value of x, and that lies in between negative 3 and 4. So negative 3 is less than x, which is less than 4, and that is the graph of the solution. It says, what is the solution of the absolute value of 3x minus 4 is less than or equal to 8? Well, think about what that means in terms of distance away from 0. It's saying the distance that 3x minus 4 is away from 0 is less than or equal to 8. It does help to draw these out on a number line so that you get a visual on what's going on. If the distance away from 0 is less than or equal to 8, there are two numbers that are 8 away from 0. You have negative 8 on the left and positive 8 on the right. So if the distance that 3x minus 4 is away from 0 is less than or equal to 8, that means 3x minus 4 lies in between negative 8 and 8. But it could also include negative 8, and it could also include positive 8. So to write that, you would say that negative 8 is less than or equal to 3x minus 4, which is less than or equal to 8. That's how you would set it up to solve this for x. The distance that 3x minus 4 is away from 0 is less than or equal to 8. 3x minus 4 lies in between negative 8 and 8. So negative 8 is less than or equal to 3x minus 4, which is less than or equal to 8. And to solve this for x, you have three areas. You have a left, a middle, and a right. You want to get the x by itself, isolate the variable. To do that, you need to add 4 to the left, the middle, and the right. So if you add 4 to the left, the middle, and the right, we end up with negative 4 is less than or equal to 3x, which is less than or equal to 12. To continue getting the x by itself, divide the left, the middle, and the right all by 3. And you get negative 4/3 is less than or equal to x, which is less than or equal to 4. Now, you calculator people divided negative 4 by 3, and you may have gotten negative 1.3 repeating. It's the same thing, or negative 1 1/3. So we're going to put a closed circle on negative 4/3, or negative 1 1/3, closed circle on 4, and then the line goes between them. So the value of x lies in between negative 4/3 and 4. Now the graph we started with at the beginning, that was showing the distance 3x minus 4 is away from 0, so less than or equal to 8. But our job here is to solve for x, and that is in between negative 4/3 and 4. It could also include negative 4/3 and also include 4. We've talked about absolute value inequalities with a less than sign, such as the absolute value of x is less than 5. That's saying the distance that x is away from 0 is less than 5. So x lies in between negative 5 and 5. Or you could say that negative 5 is less than x, which is less than 5. But what about a greater than sign? If you have the absolute value of x is greater than 5. With those two numbers being 5 away from 0, negative 5 and 5, if the distance that x is away from 0 is now more than or greater than 5, that means x would be to the left of negative 5, or x could be to the right of positive 5. So if x is to the left of negative 5, you could say that x is less than negative 5. Or if x is to the right of positive 5, you could say that x is greater than 5, if the distance that x is away from 0 is greater than 5. Going to solve this absolute value inequality. The absolute value of 2x plus 4 is greater than or equal to 6. We're going to solve that for x. That's saying the distance that 2x plus 4 is away from 0 is greater than, or it could be equal to, 6. Now it does help to draw these out on a number line so that you get a visual on what exactly is taking place. Helps you understand it better. So if you draw a number line with negative 6 on the left and positive 6 on the right, the distance that 2x plus 4 is away from 0 is greater than or equal to 6. So that means that 2x plus 4 could be out here to the left of negative 6, or 2x plus 4 could be out here to the right of positive 6. Now since that's the case, since 2x plus 4 could be to the left of negative 6 and also equal to, since you have the equal to sign with that, you could say that 2x plus 4 is less than or equal to negative 6, or 2x plus 4 is greater than or equal to positive 6. So to solve this for x, that's how you would set it up. You're seeing that 2x plus 4 is to the left of negative 6, could also be equal to. So 2x plus 4 is less than or equal to negative 6. And you're also seeing that 2x plus 4 is to the right of positive 6, could also be equal to. So 2x plus 4 is greater than or equal to positive 6. So that's how you would set it up to solve for x. Saying that 2x plus 4 is less than or equal to negative 6, so we're going to solve that for x, and also 2x plus 4 is greater than or equal to 6, we'll solve that for x as well. So if you subtract 4 from each side of that first inequality, you get 2x is less than or equal to negative 10. If you subtract 4 from each side of that second inequality, you get 2x is greater than or equal to 2. Divide each side by 2 of each inequality, get x is less than or equal to negative 5, or x is greater than or equal to 1. So what that means graphically is that x could be to the left of negative 5, could also include negative 5, that's the closed circle. Or x could be to the right of positive 1, could also include 1. Again, that's the closed circle. So the solution here is x is less than or equal to negative 5, or x is greater than or equal to 1, and that is the graph of the solution. Going to solve this inequality, the absolute value of 5x plus 10 is greater than 15. Think about what that means. That's saying the distance that 5x plus 10 is away from 0 is more than or is greater than 15. it helps to draw it out so that you can see exactly what's going on. So with the number line, the two numbers that are 15 away from 0, you have negative 15 on the left and positive 15 on the right with 0 in the middle. That is a negative 15. So if the distance that 5x plus 10 is away from 0 is more than or is greater than 15, that means it's going to be out here to the left of negative 15. So 5x plus 10 could be to the left of negative 15, or 5x plus 10 could be out here to the right of positive 15. So 5x plus 10 could be greater than 15. So that left side with 5x plus 10 being to the left of negative 15, you could say that 5x plus 10 is less than negative 15. And with it being out here to the right of positive 15, you could say that 5x plus 10 is greater than 15. So 5x plus 10 is less than negative 15, or 5x plus 10 is greater than 15. That's how you would set it up in order to solve for x. So 5x plus 10 is less than negative 15. To solve that for x, we're going to subtract 10 from each side. We end up with the 5x is less than negative 25. For the 5x plus 10 is greater than 15, subtract 10 from each side to get 5x is greater than 5. Divide each side by 5. You're not changing the inequality sign here. You're dividing by a positive. You only change the inequality sign when you're dividing or multiplying by a negative. So we're dividing by a positive. That doesn't change. It's x is less than negative 5. And that second one, divide each side by 5 to get x is greater than 1. So x is less than negative 5, or x is greater than 1. To graph that, you would put an open circle on negative 5, the arrow goes to the left, and an open circle on 1, the arrow goes to the right. So this is an or inequality. It splits off in opposite directions. Remember, an and inequality comes together. An or inequality splits off in opposite directions, so the value of x could be less than negative 5, or the value of x could be greater than 1. You take any of those numbers, to the left of negative 5, to the right of positive 1, put them into the original inequality, you'll get a true statement. If you go from negative 5 to 1, including negative 5 and 1, so anywhere in here, put those in, it'll make a false statement. So the solution is x is less than negative 5, or x is greater than 1, and that is the graph of the solution.